stuff on the properties of determinant. Any confusion? Doubts? So we have to prove it, properties of determinant based on this thing, based on the summation rule, summation minus sum of t for each. We want to reduce to I3 So then I think we have done a lot of work on last class. So with that, you can really manage well on the determinants and exercise on determinants. Now, I'll be talking about something called solvability criteria. So the solvability criteria was what I was trying to say, that there are two things I would like to address: Ax equals to 0 and Ax equals to b. When these systems are solvable, okay, the question comes that whether all the time you get solution, or sometimes you may get no solution, or sometimes you get solution which is unique or infinite. So there are a lot of issues here to be addressed. And so, can you pick up one example for this case where there is no solution from your school level mathematics? Ax equals to b. Two algebraic equations please supply to me, which will say that the system is not solvable. Then we start from there. Any idea? Just raise the hand and tell me. Raise the hand and tell me. School level mathematics, 2 by 2 algebraic system. Yes.
Two equations are independent.
No, I just want some example. Yes. Okay, excellent. X1 plus X2 equals to 1, and 2x1 plus 2x2 equals to 3. Are you sure this is the thing? Okay. So you can write 3 by 2. If you look at this system, this is actually 1, determinant is 0. So the thing is that if it's 1, the same relation is saying 3 by 2, no solution exists. But if you have 2x1, 2x2 equal to 2, in that case solution will exist, but there are infinite number of solutions. So these are the examples you can actually draw from the school level mathematics. So with that, we'll look into the formal procedure to see the solvability criteria. Okay. So first we talk about something called rank of a matrix. So what is rank of a matrix? How to define rank of a matrix? Only one hand, please. Yes.
The largest square submatrix is determined is not zero.
What is that?
The largest square submatrix is determined.
It is not a clear definition. Yes.
Number of linearly independent vectors in a matrix.
Not vectors. Not the vectors. Yes. Non-zero rows in a matrix. Non-zero rows are there. What's the rank of the matrix? So just a minute. So this is the wrong definition. Yes. You understood that why the definition is wrong? Yes. Who said number of non-zero rows? Yeah. Did you understand this? Why your definition is wrong? Okay. I explain to you.
The maximum determinant which has
No. Yes. I don't understand. So difficult definition. Yes. Some more hands. The entire class. Some more hands. Yes. Wow, excellent definition. The number of non-zero rows in the row echelon form or the echelon matrix. Now, what is the echelon matrix? I am asking the question again.
So actually, so we need to transform matrix like there will be zeros in the last row. Like
How to get it? How to get echelon matrix? Yes. Elementary row operations. I will tell you that echelon matrix can be obtained very easily. We have done Gauss elimination method. And I think all of you have done Gauss elimination method. What we do, we convert the any matrix to the upper triangular matrix by the elementary row operation. And while doing the upper triangular matrix, you will see some of the rows are becoming 0 if the matrix is having 0 determinant. So in that case, you can actually see the number of non-zero rows in the row echelon form. So what does it mean? Number of non-zero rows? That means number of independent algebraic equations. So simple definition is number of independent algebraic equation is the rank of the matrix, corresponding matrix, or number of non-zero rows in the row echelon form. So number of independent, for example, x1 plus x2 equals to 2, 2x1 plus 2x2 equals to 4. What does the matrix say? 1, 1, 2, 2. How to do the Gauss elimination? You have to multiply by 2 and subtract, okay? So 1, 1, 0, 0. So how did I get it? Which is R2 equals to R1 minus, R2 minus 2R1. Yes, R2 1, first iteration, so R2 minus 2R1. If you do that, you get 0, 0. So that means what? That means this row corresponding to that is x1 plus x2 equal to 2 is only the independent algebraic equation, other is dependent. So simple definition of rank is number of independent algebraic equations corresponding to number of non-zero rows in the row echelon form, and this is the echelon matrix. This is the echelon matrix. See, school level, see whatever doubts you have from the school level, you can actually get the answer. So number of non-zero rows in the echelon form, and this is the echelon matrix. Okay. So for this type of system, Ax equals to 0. Rank of A, I ask you, equals to n. What will you get? N is the order of the matrix, the square of matrix. Rank of A equals to n. What will be the case if the rank of A equals to n? Determinant of A is 0 or non-zero? Non-zero. What solution you will get? Unique. And what's the value of the solution? 0. Trivial solution. So now rank of A is less than n. In that case, determinant of A equal to 0 because some of the rows will be 0 in the echelon form. And if you do the elementary row operation, determinant will get unchanged. We have seen in the last class. After elementary row operation, determinant is unchanged, right? We have done that. That if you multiply alpha with jth row and add with I, and it will become, determinant will become unchanged. So determinant of this guy and determinant of this guy will be same. And you see that any row is 0 means determinant has to be 0. One can actually prove that, and in that case, is a rank, and in that case, rank will be less than the order of the matrix, and it should be this one. Rank of A less than n. Okay, I'm sorry. Rank cannot be more than n. So rank of A is less than n. In that case, element is 0. And what is the solution? X. Infinite, non-trivial solution. It will be infinite. So you get here trivial solution. Trivial, unique solution, and here you get non-trivial, infinite. So you get non-trivial, infinite solutions. You get non-trivial, infinite solutions. So with that, we can start on different example problems. Minus x1 plus x3 plus 2x4 equals to 0. Minus x1 plus x2 minus x4 equals to 0. Minus x2 plus x3 plus 3x4 equals to 0. x1 minus 2x2 plus x3 plus 4x4 equals to 0. Answer is, what is the nature of the solution? Okay? What's the nature of the solution? By simple look, you can easily say that, okay, the 4 unknowns, 4 algebraic equation, Okay, looks like determinant of A is non-zero. We make a trivial solution. Let's look at that. So this can be converted to Ax equals to 0 system, and your A matrix is minus 1. Then tell me quickly. Minus 1, 0, 1, 2. Then minus 1, 1, minus 1. Then 0, minus 1, 1, 3, 1, minus 2, 1, 4. Excellent. Okay, now do the elementary row operation. Right? So in the elementary row operation, what? So this is unchanged. So only you have to play on that. And first is you have to make this guy 0, this guy 0, this guy is already 0. So to do that, so it will be R21 should be R2
Minus. No, not mine.
minus R1. Okay? And then R41, this is R4 plus R1. Am I correct? Okay. Minus 1, 0, 1, 2. Then 0, 1,
Minus 1.
minus 1, minus 3. Am I correct? 0, minus 1, 1, 3. Then 0, minus 2, 2, 6. Am I correct? Yes? Okay, now we can say everything is 0 here. Now we have to talk about these two guys, and we will be operating based on this second row. So it will be now what? R3 2 equals to R3 1. This means number of iterations. Remember that. First iteration, second iteration. R3 1, then it will be operating with respect to second row. First operation is over. Second row. R3 2 equals to R3 1, then how to get 0? Plus R2 plus R2 1, right? Please say R2 1. Then R4 2 is R4 1,
Plus 2.
then plus 2 times R2 1. 2 times R2 1. Then minus 1, 0, 1, 2, 0, 1, minus 1, minus 3. Then 0, 0, 0, 0, 0, 0, 0. Rank of the matrix is number of independent rows in the echelon form. It is 2, and you can say that first two equations are the independent algebraic equation and last two are dependent. So that's the clear-cut concept of the rank of the matrix. The clear-cut concept of rank of the matrix. So rank of the matrix is 2, and number of independent algebraic equations 2, and number of independent rows in the row echelon form. Now for these kind of things, here in that case you can say that okay, based on our form we can have infinite non-trivial solutions. We can have infinite non-trivial solutions. And in that case solution belongs to a space and which is called as null space. So we're talking about something called null space basis. We're talking something on null space basis. We're talking something on null space basis. So it says that when you have solution, if solution of Ax equals to 0, when you have solution of Ax equals to 0, the solution exists, and the solution belongs to the null space. And the basis, of course, the basis of null space is infinite, but dimension of null space can be determined. Basis of null space is infinite. However, the dimension of null space is finite. Dimension of null space is finite. However, the dimension of null space is finite. Okay, how to find the dimension? How to find the dimension of null space? So now we can see that there are two independent algebraic equations, and what are they? Minus 1. So independent algebraic equations plus x3 plus 2x4 equals to 0, minus x1 plus x2 minus x4 equals to 0. We found out. Only two independent algebraic equations. Last two are dependent based on our row operation. That means so that means we have got two independent algebraic equations and two unknowns. Based on our degree of freedom, two variables we can fix by yourself. Based on that, we can get the solution. Okay? So we can assume x3 equals to alpha and x4 equals to beta. If we assume, then only we can get the solution of x2 and x1 in terms of alpha and beta. Right? So what do you get? x1 equals to alpha plus x2 equals to here there is no x2 here. Okay, here alpha is actually here minus alpha, this is minus beta, right? Okay, how much it is? x1 plus x4 then alpha plus 2 beta, how much it is? So your solution x bar, which is x1, x2, x3, x4, which will be alpha plus beta. What is that? Beta 2. So dimension of null space is alpha and beta, so 2. So there is uniqueness of dimension of null space. Okay, there is uniqueness. So dimension of null space talk about how many arbitrary constants we are actually fixing. Of course, number is 2 arbitrary constants. And alpha and the beta, the scalars. Alpha could be 2, beta could be 2, alpha could be 3, beta could be 3. You can see in that case, these are the bases of the null space solution. And you can have infinite bases, but we have finite dimension of the null space. One is clear. So my entire solution for this system is given by this. The solution for this algebraic system is nothing but alpha into 1110 plus beta into 2301, which show this application in the formation of eigenvector. Have you done eigenvectors? Okay, my question is, an eigenvector, this was the equation, right? The same kind of thing. Did you use null space? Then that means something you were doing wrong earlier, right? You didn't know null space, because without null space you cannot get eigenvector. You cannot get, because the same kind of thing. It's just that you can say this is nothing but bx0. This is eigenvalue problem. So this entire exercise belongs to eigenvalue problem. And determinant of b is what? Determinant of b is what? 0 to the characteristic equation, right? Determinant of a minus lambda equal to 0. So exactly the same kind of formula, same kind of things can be replicated in eigenvalue problem. And your solution, or the eigenvector, so the eigenvectors must lie in null space. So that's the application of null space. Without null space, we cannot do eigenvector. And whatever you have, I don't know how much eigenvectors are actually done with. Getting eigenvector is not easy, it is very complicated. So you can see that without knowing null space, you cannot have eigenvectors. Any comments here? Any comments? No comments. So basically the conclusion is we need to have this type of basic analysis. This is a null space basis. Then the solution for that system, and that actually this type of concept would be useful for the eigenvalue, eigenvector problem. Okay. So any doubts on null space? Everything is clear to all the people? Any questions, confusion on the null space? Any questions, confusions? No questions. Okay. Next we'll be talking about. So we have seen the dimension of null space is actually 2. So that we have seen. Next, we will be talking about something called a range space. What I have done here, I will put B1, B2, B3, B4. Problem has been changed now. Instead of right hand side 0, I have having B1, B2, B3, B4, Ax equals to B. And now we have seen determinant of A equals to 0, right? For this case. When can you get unique solution? For any B's you can get unique solution. If you are really confused, you pick up today's example. x1 plus x2 equals to 1 and x1 plus x2 equals to 1.5. Of course, not for any B's. If it is 1, then only you can get solution. Otherwise you won't get solution. Then how to represent mathematically the condition for solvability for this system A is equals to B? Let me repeat once again. How to establish mathematically the condition to obtain the solution for X equals to B. How to establish mathematically to obtain the solution for X?
Length of the vector after linear transformation should be equal to the rank of the matrix. Length of the vector formed by.
What is length of the vector?
As in B1, B2, B3, the vector which is formed. And the rank.
I am not getting that. Okay.
Rank of A should be equal to the rank of augmented AB.
Okay. Excellent answer. Excellent. Did you study this one earlier? Oh, you have not studied. Okay. Answer is your friend gave rank of A should be rank of A augmented B. Rank of A augmented B. What is that? So, it is possible to have augmented matrix. Augmented matrix means you have got B vector. If you construct a matrix where your last columns are the B vectors entries, then the matrix is called as augmented matrix. A matrix, B matrix. I can form a matrix which is non-square matrix whose last column are the entries of the B vector. In that case, matrix is termed as augmented matrix. Clear? So, the augmented matrix is, I write this way, which is for our case -1, 0, 1, 2, B1. Next is -1, 1, 0, -1, B2, 0, -1, 1, 3, B3, and then 1, -2, 1, 4, B4. We can put like this for augmentation. This is augmented matrix. So now do the same operation. We have done two operations, right? To make it, so what operation you will do? You will make sure we will do the same operation like the upper triangular matrix. By doing that, you have to see is this satisfied. That means number of non-zero in the echelon form of this should be equal number of non-zero rows of the echelon form of this. In that case, you get solution. Okay, it makes sense. If you put 1, what actually happens when this is having 0, 0, this also has 0. Right? So your augmented matrix is 1, 1, 1, 1, 1, 1. So when you make it 0, this is automatically 0. If you have 1.5, this is not 0. Not equal to 0. In that case, rank of A is not equal to rank of the augmented B, and that's why you could not get the solution. Right? So that's the school level. So whenever you get stuck, go to the school level mathematics, and that's why mathematics is so easy. Everything is based on the school level stuff. Okay. Operation, please tell me. You already have it. What's the operation here? Operation R21. R21 equals to R21 equals to R2 minus R1, then R41 equals to R4 plus R1. What do you get here? -1, 0, 1, 2, B1. Next is 0, 1, then minus 1. What is that? Minus 3, and then B2 minus B1. Am I correct? Third is as it is 0 minus 1, 1, 3, B3. Fourth is 0 minus 2, 2, 6, B4 plus B1. Yes. Yes. Okay. Next is, what's the operation for next step? R3 2 equals to R3 1 plus R2 1. Then R4 2 equals to R4 1 plus 2 R2 1. Okay. Minus 1, 0, 1, 2, B1. Then 0, 1, minus 1, minus 3, B2 minus B1. 0, 0, 0, 0. What is that? B3. B3 minus plus B2 minus B1. Next is 0, 0, 0, 0. Then B4. B4. B4 minus B1 plus 2B2. B4 minus B1 plus 2B2. Yes or no? Yes? Is it wrong? B4 minus B1 plus 2B2. Now here you can see that situation is different from the non-space equation and range space equation. Here you can see you got two relationships. These two both have to be 0. Otherwise your rank of A cannot be rank of A augmented B. In order to have rank of A equals to rank of A augmented B, this has to be 0. This has to be 0. Alright? So what are the equations you got? B3 plus B2 minus B1 equals to 0, and B4 minus B1 plus 2B2 equals to 0. In the null space we considered the first two independent algebraic equations. Here you are considering these last two based on the rank of the matrix A and rank of A augmented B. And here again we can see that there are four unknowns, B1, B2, B3, B4, and 2 you can actually select your own, okay? And based on that you can actually, so you can have here B1 equals to alpha, B3 equals to alpha prime, B4 equals to say beta prime, and B vector you can actually have as alpha prime plus beta prime. What are they? Can you put the entries? Can you put the entries? So in that case, Ax equals to B, we will have the solution, and based on the vector B, where B vector should be in the range space. Okay? And what is the range space? Of course, these are the basis of the range space. So what I said, Ax equals to 0. The solution of X would belong to the space called null space, and for Ax equals to B, solution would exist if and only if the vector B belongs to range space. If and only if the vector B belongs to range space, and the dimension of range space is fixed, but you can get infinite basis of the range space. The dimension of range space is fixed, but you can get infinite basis of range space. So can you please tell us what is the fill in the blanks? Fill in the blanks. Two by 3 here. All entries B1, B2, B3, B4. How can you say 2 by 3? What is 2 by 3? I don't even know, understand. What are the points here? 1, 0. Okay, I got one answer. 1, 0, 1, 1. Next. 0, 1. Minus 2. All of you agree with this? Yes or no? 1, 0, 1, 1, 0, 1, minus 1, minus 2. All of you agree? Yes? Which one? First one is 2, 1, 1, 0. Is that correct? 2, 1, 1 0. This one
minus 1, minus 1, minus 1.
minus 1
Minus
0.
1, 1.
How many 1? 5 is coming. You said minus 1 0 1 1.
Minus 1, minus 1, 0.
Minus 1, minus 1, 0.
2 1 1 0 and this is minus 1
Minus 1, 0.
minus 1 1
Minus 1, minus 1.
again 0 1. That's what I said, no? Yeah. So you can see that if you put alpha prime, beta prime, any numbers, you can get infinite basis. But the dimension of range space is 2. So dimension of range space is how many B's you can select arbitrarily so that your solution is fixed. The solution belongs to the space which is called as range space, and the dimension of range space is equals to what happened? What happened? No, if you think you can discuss and learn, then I should be sitting here. He can teach here, no? Right? This kind of attitude I don't like. If you do it, I cannot teach in the class. I take so much of pain. If you think he's a better teacher, I will invite him to come here. I can sit there. I will be very happy to see that. Okay? Any question on this? Any doubts? If you have any doubts, please ask me. I am always addressing the doubts. And if you think to ask doubts, you will be called the unsmart guy or not talented guys. That's okay, but you are learning. So there is always leave the ego and ask the questions. Nothing will happen. You will be the gainer. The people who are having ego, they are always losers. They cannot learn much because they have the ego. Okay? Any questions? Any doubts here? Non-space, range space, clear? Dimension of non-space plus dimension of range space is the order of the matrix. Dimension of non-space plus dimension of range space is the order of the matrix. So dimension of non-space you got 2, dimension of range space you got 2, order of matrix is 4. Right? Dimension of non-space plus dimension of range space is the order of the matrix. How to prove it? Exam problem maybe. Show that dimension of non-space, dimension of range space is the order of the matrix. How to prove it? You can look into that, and that could be the exam problem. Okay, so all this exercise, we have done so much exercise, we will apply this to chemical reaction engineering. So as I said that whatever mathematics we do, it has got relevance, otherwise that mathematics we don't do, because this course is material methods and chemical engineering. Okay, so we will start picking up example on chemical kinetics. CO plus 2H2 equals to CH3OH. CO2 plus H2, H2O plus CO, CO2 plus 3H2 equals to H2O plus CH3OH. Then simple reaction from methanol synthesis. Simple reaction from methanol synthesis. Okay. The question comes. Chemical reaction engineering is a simple thing, but sometimes, for example, combustion reaction or atmospheric, for example, if you talk about the ozone formation in atmosphere, we have how the ozone actually forms. Any idea? What are the basic reaction? What is the basic reaction to ozone formation? Don't say O2 plus O equals to O3. Yeah, don't say that. Don't say that. In nature, how ozone forms? What is that? Simple. In the nature, how the ozone forms? We have got so many cars are actually moving. We have got the nature. You have seen that nature has what? Human beings, cars, trees, everybody. From nature, continuous ozone being formed. How the ozone forms? Okay, the answer is VOC plus NOx, volatile organic components, which is actually emanated from the all vegetables or the trees, everything. and NOx actually the NOx, it is coming from mostly from the cars. Okay, so that's why NOx reduction is one of the big issues in US, and people are spending millions of dollars on the thing. So we actually have something called VOC plus NOx, which will give O3. But it's not a simple reaction. There are 1,000 reactions here. Okay, and the situation is, if there are 1,000 chemical reactions, do we need to consider all the 1,000 reactions, or do we need to consider independent reactions? Some of the reactions could be dependent. So, question is, can we treat this as algebraic system? Can we treat as algebraic system? So, in that case, it is possible to treat this system as this nu is the matrix. This matrix is known as the stoichiometric matrix or the stoichiometric tensor. So this matrix is termed as a stoichiometric matrix or a stoichiometric tensor. Now you can see how much of mathematics is involved in chemical reaction engineering. We have tremendous mathematics. So we have to express this entire system in an AX equals to 0 form. I didn't write AX because the special matrix we term which is called as a stoichiometric matrix, and from there we know the solution belongs to null space, and number of independent reactions is based on the rank of the matrix. So if you find the rank of the matrix, we know how many independent chemical reactions are there. Based on that, you can proceed your calculation. Okay, so let's look at how many independent chemical reactions are available for this system. So in order to do that, we will denote the product as positive sign. When you define the value, the product will be having the positive sign, and the reactant will have the negative sign. We'll have the product will be having the positive sign, and the reactant will have the negative sign. Okay, this chemical reactions looked at in the vector space and tensor were proposed in 1967, and there are people who are called as the father of mathematics in chemical engineering. Before 1950s, hardly people used to do mathematics in chemical engineering. They used to go to the chemical factory, and that's the way chemical engineering used to run. There's a person called Amundsen. BSc Mathematics Honors, MSc Chemical Engineering, PhD Chemical Engineering, all from University of Minnesota. He did, I think, PhD in 1945, University of Minnesota. What he did, when he was doing BSc Mathematics, he found chemical engineering friends, and he was fascinated to see so much of mathematics in chemical engineering. And he and his associates called Alice, there is a book by Alice and Amundsen. They defined chemical reactor is a space, is a vector space, and they call precisely, I am talking about the vector space, and they call it a vector subspace, a subspace. So chemical reactor he treated as a vector space. Just see that. So the concept was given by Amundsen, 1945, and based on that, the entire chemical reaction engineering was defined in tensor format. So you have heard something called vector and tensor, right? And some of the portions of the vector and tensor will be covered in next semester in transport phenomena course. But the entire chemical reaction engineering, chemical kinetics can be written in a tensor format. And as I told that, physicists actually, as I always tell that, physicists can talk about the dimensions called x direction, y direction, and z direction. Sometimes astrophysics called time as also one of the independent axes. So they are the fourth dimension, astrophysics. Chemical engineering is much above. Chemical engineering has n dimension. Why? Because from the vector and tensor, it is possible to have each species called as independent species, and each species would act as an independent axis, and it is possible to have n independent species, and we can get n order tensor, okay, or n dimensional vector space. So I'll be talking much, and you can actually coordinate. And this was possible for Professor Amundsen, and he after that subsequently he graduated so many PhDs and who talked about mathematics. One of his close associates is Professor D. Ramakrishna in University of Purdue, and there are lots of people who have been influenced by that, and partly I was also influenced by him. I was doing my postdoctoral fellowship in University of Houston, and he was the chair professor in mathematics, and he was one of my advisors. And he wrote a lot of books. And when I told that, okay, I'm going back to India to teach in IIT, he was in his late 80s or early 90s. I still remember. I went to I went to take his blessings in his office, and he gave his book. He said, I'm giving you my book, and please go to India and teach from my book. So whatever I'm teaching in the class, some of the parts I've been influenced by this legendary of mathematics. I was so fortunate to work with him. His name is Bernard Amundsen. Okay, so with that, I would like to continue. So, so the vector x will have CH3OH. So I will treat all these components as variable. Okay, so CH3OH, CO, H2, CO2, and H2. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Yes, that's it. These are the species. And as I said, when I construct the algebraic equation from here, the product is positive and reactants are negative. So this equation will be having what? CH3OH is, so you can say this is your X1, X2, X3, X4 and X5. So first algebraic equation will be what? CH3OH is X1 minus X2 minus 2X2, sorry, 2X3 equals to 0. Am I correct? Second equation, H2O is positive. It should be positive. So H2O will be X5 minus plus X2 minus X4 minus X3 equals to 0. Next is H2O, which is X5 plus X1 minus X4 minus 3X3 equals to 0. Am I correct? Yes. Stoichiometric tensor. What is that? 1 minus 1 minus 2 0 0. Am I correct? Next is 0 1 0 minus 1 1 0 1 minus 1 minus 1 minus 1 minus 1 1 and then 1 minus 3. Do the echelon form. So this is already 0, so you have to make it 0. And how to make it 0? R3 minus R1. Okay, so you get R31, which is R3 minus R1, which is 1 minus 1 minus 2 0 0 0 1 minus 1 minus 1 1, and this is 0, then 1, then minus 1, then minus 1 1. So next will be R32 will be R32 will be R31 minus R21. Okay? R21 equals to R1, R20 because this has not been changed. So we have 1 minus 1 minus 2, 0, 0. 0, 1, minus 1, minus 1, 1, 0, 0, 0, 0, and 0. So it's in a simple system you can find that these two are independent chemical reaction, and this is dependent. So when you do the chemical kinetics operation, first two equality chemical reactions would be adequate to analyze. This same thing will be applicable. If you have 1,000 chemical reactions, you can easily find by this technique how many independent chemical reactions to analyze the system. And this will be applicable, I think, when you be, so please try to learn as much on this, because I think thermodynamics course, when chemical reaction equilibrium and chemical reaction thermodynamics course will be taught, I think Professor Ravi will be referring to this technique. So this is pretty much important for your chemical reactions and thermodynamics. Any questions? No? Okay. Next, I am now talking lots on the application of null space and the relatively Schutz rank of the matrix. Next thing is that I would like to be a bit philosophical in this context, at this juncture. That when actually we have learned fluid mechanics, we have talked about different numbers like Reynolds number, Euler number, and all those things. And the thing is that when the fluid flow will get Reynolds number, Euler number. When hot fluid is flowing through a tube, you get Nusselt number. When the mass transfer occurs, you get something called Schmidt number, Nusselt number, all those things. On what is the basis of these numbers and why they are defined like this? Are there a mathematical basis? For example, we have dV rho by mu, which is Reynolds number. Okay, it could be something else, no? Why this kind of dimensionless? I can have some kind of dimensionless mechanism. I can have some dimensionless mechanism. How we can actually have V and D is the diameter versus time. Dimensionless. So easy to, you can see velocity is also velocity unit. Okay? Or we can have rho, which is density. M density is kg per meter cube, ml minus 3. Right? The dimension, mass minus 3. What we can have? We can have mass, m you can write mass, and then we can have velocity cube into p. Is it dimensionless? You could have had this dimensionless quantity. Why we had this? You cannot do this. So dimensionless quantities can be obtained by any arbitrary manner, right? Why we came up with Reynolds number for the fluid flow? Why we came up with Nusselt number for the heat transfer? Are there any basis? The basis is we can say that, okay, Buckingham pi theorem. Have you heard? So something called Buckingham pi theorem. What is that? Buckingham pi theorem? Any idea? What is Buckingham pi theorem? No idea. How many of you are aware of this Buckingham pi theorem? Yes. I am not able to hear what you are saying.